Hey everybody, John from Additive Alliance here with another installment video for my series on how to build a 3D printer. Today let's do a brief summary of electronics, what it might take to drive a printer. We'll use the NX3D as our example right here. So let me spin the camera around and get into all the naughty bits it takes to make it work. Okay, so here is an electronics panel from an NX3D machine. It looks a bit intimidating because there's a lot going on there and it looks a little bit like spaghetti, but it's actually a pretty logical flow and pretty straightforward when you understand what each of the discrete components does. They all have their own purpose and reason they're there. And what I'll do is I'll just use my long tip screwdriver as a pointer here, and we'll go through the flow of power through the unit, so to speak, and kind of describe the purpose of each of the devices you see there and how they interface with each other. So let's start with, down here in the lower left you can see a plug, which is wall power, aka line voltage coming in, line current. And it comes into a standard IEC plug and a switch, and over here you can see it's grounded to the frame with a double lugged M4. Make sure your unit is grounded. It's just a good safety idea. If you get a short anywhere, you don't want to hurt anybody. Make sure that your line power is insulated and well secured, preferably with screw-on connectors. And you can see the line power then comes up to this supply, which is a 24 volt 450 watt supply, and then continues on up into a 48 volt 350 watt supply. The unit runs mostly off the 24 volt supply. 24 volts then comes down into these pair of buck converters. These are off the shelf. I like the ones that have the digital display on them. They have a potentiometer on them, so you can just dial them into whatever output voltage you want. Again, I like the ones that you don't have to hook a meter up to and you can see exactly what you're getting. You can buy a whole different variety of these things. Some are better than others. These have a 5 amp output to them. Make sure that whichever ones you choose have enough power output to drive whatever your power budget is downstream. The 5 volts in this case then goes over to this board with the flashing light on. That's a heartbeat. Lets me know the software is still alive. And this basically acts as both a watchdog timer and a 5 volt power distribution board. 5 volts then comes from here to a variety of other places. It goes to these two boards, which are power control boards, we'll talk about in a minute, to the PWM. It's a 16-channel PWM board you can buy off the shelf, to a 12-bit 4-channel A to D. You will need to convert analog signals such as RTD or thermistor or any other analog signal into a digital signal. And 5 volts then also drives a Raspberry Pi. In this case it's a Pi 4, but I've driven this unit off with anything from a Pi 3B all the way up to a 5. I believe this is a 4 with 2 gig, works just fine. There's an 8-channel set of relays right here. These are just mechanical relays. They'll switch anything based on a Raspberry Pi signal. I have a couple of them switching 5 volts, maybe a couple switching 12. One of them turns the lights on and off in the unit. Another one actually switches raw 24 volts out at the tool. And then down below here you can see the motion controller, which is the tiny G that I mentioned in the motion control video. That is driven directly off of the 24 volts. It drives its own fan and does its own logic voltage. A couple of tidbits here. I use Molex MiniFit Junior connectors exclusively through the unit. You can see the panel mount version here, cable mounts, floating cable version here, PWE versions there. They're very reliable. They come in a whole array of sizes from 2-pin to 4-pin to 8-pin, even more. They're a little pricey in the sense that you have to buy a good quality crimping tool on the order of $250 to use them. You can buy a cheaper crimping tool for like $50, but it's not nearly as nice or as reliable or make as good crimps as their official tool does. The wires coming off of the Tiny G, notice that these are all not any of those wires you would get with a stepper motor as you buy them, and I found those wires to be horribly unreliable, and convert all of them over to these cables. The cables are some cables I use are shielded, some are not, depends on where I am sending the signal. Cables that are tightly wrapped with each other up top here that go out to the tool are shielded, because I don't want the heater signal crossing with the stepper signals that go out there. But you can see some of these cables, like this one right here that goes out to the Z motors. They work in sync, they're going off the same signal, and they don't run with anything else, so therefore they're not shielded. The discrete pin-to-pin connections was a hard lesson for me. I had started out using these style connectors. I'm not sure I can get the camera to focus on them, but they're kind of these bulky generic style. You can find them all over Amazon, but they turn out to not provide a very tight fit onto the pins, and they can become horribly unreliable. So I did some shopping, and I found these guys, which are much tighter fitting and much more reliable. These are really great. Again, they're a little more expensive, but they are well worth it. With this many interconnects, you need something that is going to be up at that 6 sigma level. I believe that they're made by this company called Smartboard, with a SCHMART board. This is an example of the black ones. But you can get them in a variety of lengths and in colors, and they've been really great. They work very well, and given your machine will be shaking and rattling, you need something that has a very positive connection. The power supplies, these two guys are Meanwell, and they've been very reliable as well. I've tried some off-the-shelf supplies in the past that you can buy on Amazon or other resellers, and they're a little bit cheaper, but boy, those those knockoff supplies do not work well at all. As soon as you put a load on them, their voltage drops and dips, and they just don't even come close to meeting the spec that they advertise. So consider yourself warned that you buy the right supply, and you want to just pay the extra money for something reliable. That's it in a nutshell. The two boards that I kind of glossed over, this timer board, power distribution board, and these power control boards, I will talk about in depth on separate videos. They are custom built boards that I designed myself because I could not find anything off the shelf to satisfy the requirement. In addition to power distribution, this acts as a hardware watchdog to make sure that the system doesn't go out of control, hence the heartbeat. And these guys act as power regulators. They take the raw power in and PWM signal in, and basically output a power through MOSFET control that is proportional to whatever your PWM drive is. So I use the 24 volts to drive the tool, as well as the 48 volts out at the tool as well, but the 48 is also used to drive the build table heaters so that they heat up in a reasonable amount of time. Okay, so there you have it. That's a quick summary of the electronics. As mentioned earlier, I will do a separate video on those power regulator boards. They're worth it, worth their own discussion. And in the safety video, I will talk about what that watchdog timer does. Both of them are pretty critical to solid operation of a unit, so they're worth their own video. Anyway, if you have questions, comments, smart remarks, go ahead and leave them in the comment section. Love to hear from you. Have a great day.